The last conic section we're going to talk about is the hyperbola. Pay particular attention to the vocabulary words up here that you need to know. The most important ones, or the least important one, is the foci. You don't really need to worry about that once we've defined it, but you should understand everything else that's up there. The hyperbola looks kind of like a parabola, except it's pointier than a parabola. But the most important thing is that it has two branches to it, two pieces that look kind of like a parabola. An example of parabolas in real life would be the sides of the cooling tower. Right here is one piece of the parabola, or the hyperbola, and here's another piece of the hyperbola, and together they make up the whole hyperbola. You will also see hyperbolas used in sonar and radar. Okay, so here are the equations for a hyperbola, and I find it useful to just think of this really as one equation here, right here, this right here, and this right here. They're really the same thing. What's different, they look a lot like ellipses, but what's different about them and what's different about the equation for a hyperbola versus an ellipse is the minus sign in there. The equation for an ellipse, both of them are positive, so it doesn't matter what order we put them in. For a hyperbola, either the x squared or the y squared, but not both, are negative. They can't be both because then it would turn into an ellipse. If they're both positive or they're both negative, then it's going to be an ellipse. So, the differences between the two equations are that in a hyperbola, you need to look for the minus sign, and that will tell you which direction it's opening. The example right here has the hyperbola crossing right here and right here, crossing the y-axis. In that kind of a hyperbola, the y is positive and the x is negative, so it's going to be an equation that looks like this. In the one we saw on the previous page, where the hyperbola crosses the x-axis like that, that's the one where the x is positive and the y is negative. So you need to pay attention to what's positive and what's negative with that. There are lots of things in this slide that you can, lots of vocabulary words. I'll go through the vocabulary words as we graph a couple, but you should know all of these words and how they relate to the graphing for graphing hyperbolas. Shown in this example here, this slide here. If you're interested in more information, just check out these two links right here, and they'll tell you more about how they're used. I'm going to focus on the equations that you need. Okay, so let's look at how you would actually graph this, starting with this first one right here. Since the x is positive, we know that this hyperbola is going to cross the x-axis. We also know that there's no left-right shift and no up-down shift, so the center of the hyperbola is going to stay at 0, 0, since we don't see any h or k values in this equation right here. So let me move this up. We're going to put the center at 0, 0. And then we're going to look at what it isn't the radius, but it's like a radius. Underneath the x, we see a 4. We want to take the square root of that, that's 2, and go out 2 on the x-axis and back 2 on the x-axis. Then we're going to look at the y value, the number that's underneath the y squared. That's 16. Square root of 16 is 4. That means we're going to go up 4 on the y-axis and down 4 to get the other points that we need. Once you're done with that, you want to draw a box that connects, or that goes through those 4 points. So you have a box. This is not part of your hyperbola, but it's going to be used to graph your hyperbola. The other thing you want to do then is connect the corners of the box with the center, so you end up with a line going diagonal that way and a line going diagonally this way. Those are your asymptotes, and that's going to help you to graph the hyperbola. At this point, you can check the distance to the vertices. Well, we know the vertices are on the x-axis, so we look at the 4 again and say, okay, the square root of 4 is 2. Does that match with our picture? Yes, it's 2 here and 2 here. And that thing that I just filled in is the transverse axis that connects the two vertices, which we'll get to in a minute, but it connects the places where the hyperbola meets the box. So the length of the transverse axis is 4, 2 times 2. The conjugate axis is the other one. It kind of goes up and down here. It's not actually part of the hyperbola, but it helps you graph the box. Square root of 16 is 4, and then we have the 4 up and the 4 down, so that'll give us 8. When we go to graph the hyperbola itself, we're going to use each one of the vertices here, the places where the box is going to meet the hyperbola, and then we just need to sketch in the hyperbola, having it go from each vertex out, getting closer and closer to the asymptotes. So the center of this hyperbola was at the origin at 0, 0. That's the center. And the two vertices are here and here. And then we want to write down the coordinates to back and to forward from the center. Slope of the asymptotes, depending on whether you need to put in the actual slopes or the actual equations for the asymptote or just the slope, you can get the slope from looking at the box. So if we're looking for rise over run in the box here, we rose 4 and ran 2, so the slope is 2. But remember, there's another asymptote down here, so the slope of the asymptotes is plus or minus 2. And if you need an equation for the asymptote, then you can do this. It's best in point slope form. Y minus the y coordinate of the center equals 2, plus or minus 2, and then x minus the x coordinate of the center. So try to graph this one now, the second one here. See if you can graph that. This one, let me move it back. And then come back and check. Okay, notice that a lot didn't change with this one. The box was exactly the same size, the asymptotes were in the same place, the center was in the same place, all that was the same. What changed was where we graphed the hyperbola after we had the asymptotes. This one went up and down rather than side to side, but you can see that not much else changed because the 16 is still under the y squared, the 4 is still under the x squared, so the size of the box and all that are the same thing. We reversed the length of the transverse and the conjugate axes because now the transverse axis runs this way from vertex to vertex, and the conjugate axis runs this way, but they're still the same length, and the asymptotes are the same, so we use the same equation. Okay, to graph this one, there's a shift in the center, so you need to think of this as actually being over 1, and then everything else is the same as what we did before. The center is going to shift to negative 2, 3. Notice that we did the x coordinate first, even though it came second in the equation, and then we did the y. The distance to the vertices is going to be along the positive part of this. So we want to look for the y value. The y squared was the positive part, so the distance to the vertices is 1. The transverse axis is going to be double that, or 2. And the conjugate axis is going to be the square root of this number doubled will be 3. It's often easier to see that from the graph, to graph it and then come back and just check that everything else works. So I'm going to go ahead and graph it, you should too, and then compare. Okay, check to make sure that you got your hyperbola going the same way, up, down, that you moved the center to negative 2, 3, that the box was 6 wide and 2 high, and you put in the asymptotes. The slope of the asymptotes is plus or minus 1/3, plus and minus, and then I put the equation for the asymptotes down here. Okay, looking at this next one, you know you're going to need to complete the square. I'm not going to do the whole problem for you, but be particularly careful with your minus signs. When you separate out the y values, that's going to be fine. You can just factor out a 6, but when you do the x's, you're going to have the minus 4x squared minus 8x equals negative 26. You're going to need to factor out the negative 4. That turns this into a plus 2x. Then when you go to complete the square, remember that you're going to be adding a plus 1 in here, which is going to translate to taking negative 26 and then subtracting 4, because you need to distribute that minus 4 back to the plus 1 to figure out what you're adding. So check to be sure you can do that one. And then let's look at these where you need to go the other way and you need to write the equation based on what you see in the picture. Some of this is going to take a little bit of kind of guesswork to figure out where things are. If we're looking at this first one, we know that since this is going to cross the x-axis, that the variable that with the positive term is going to be the x part, or the x variable. The center is at 1, negative 2, and they told us that right here. The distance to the vertices is 2. So that means that we're going to have x minus the x value of the center squared. That's going to be our positive term over 2 squared. The distance to the vertices squared is 4, minus y plus 2 squared. That's again to the center. And now we have to figure out how high up the box goes, only they didn't draw in the box for us. But if you look at this point right here, you can see that it seems like it hits on a grid line, and sometimes you'll just have to kind of go with it. But it looks like that's up 1, 2, 3, 4. So that piece of the box is 4 high. So that means we can put 4 squared, or 16, down here equals 1. The length of the transverse axis is 4. Length of the conjugate axis is 2 times 4, which is 8. This 4 came from the 2 squared, and the 8 is from the 4 squared. And then the vertices are in the picture right here. If you look over at this picture, it's a little bit more difficult to figure out the length of the box. You might try doing the slope, which is over, looks like it's over 2 up 1.5, or over 3 up 2. I would just pick one that hits as close as you can get to a grid line and go from there. Or see, the box looks like it's about like this, and so that means that if you get rid of all this stuff so you can see better, it looks like the box is about 1, 2, 3, 4, maybe 5 wide, and you can just use that 5 in your equation even if it's not exactly precisely on a grid line down here somewhere. Just use that 5. Okay, check to be sure that you can do these once you know what it is that you are doing with the hyperbolas. Maybe graph a couple, try the homework, and then come back and check with these.